Hey everybody, Dr. Nelson here. This is a lesson on something called two variable inequalities. Alright, so the first couple pages are some notes, so please follow along with me. And then there'll be some problems for you to try, and then at the end you can see how you did. Alright, so take a look at the first page here. And this really shows you the difference between what a one variable inequality looks like compared to a two variable inequality. Alright, so here we have a one variable inequality. We have n plus 9 is greater than or equal to 12, right? And if you solve for n, you get n is greater than or equal to 3. So all the values greater than or equal to 3 are solutions, right, to the inequality. All right. But here we have a two variable inequality. Notice we have an x and we have a y. Okay. And this one is much more than just a line, right? Any value that's in the shaded region, that's in the purple, okay, is a solution to the inequality. So, for example, 0, 0 is a solution to the inequality. If I go over 2 and up 2, that's in the shaded region, right? So that's a solution. Okay, so any value in the shaded region is a solution to the two variable inequality. All right, so if you turn the page, let's determine, let's talk about solutions of two variable inequalities. All right, so here it says when you're looking at two variable inequalities, you have to make sure both variables make the inequality true. Okay, so here's an example that I did out for you already. The question is negative 1, 4 a solution of y is greater than 3x plus 8? So if you notice, I plugged in a negative 1 for x, right? And I plugged in a 4 for the y. And when I simplified it, it ends up being 4 is greater than 5. Now, because that's not true, okay, this is not a solution. All right, so negative 1 and 4 is not a solution, okay, of this two variable inequality. All right, look at this one over here. Here the question is 3 and 10 a solution of y is less than or equal to 5x minus 4? And what I did is I plugged in 3 for x and 10 for y, right? And after I simplified it all, I got 11 is greater than or equal to 10. Because that is true, okay, 3 and 10 is a solution to the two variable inequality. All right, so the way to do is you have to plug in the x and y values, all right, into the inequality, and if the statement is true, then you know that x and y value is a solution to the inequality. All right, so why don't you pause the video and try the your turn problems now, and when you're done, hit play. You can see how you did. All right, good luck. All right, welcome back. Let's see how you did with these practice problems. Okay, so here we have y is greater than 2x plus 11, and the question is negative 2 and negative 1 a solution to this two variable inequality? All right, so we know the x value is going to be negative 2, and the y value is going to be negative 1, right? So I'm going to substitute these values in. So negative 1 is going to be greater than 2 times negative 2 plus 11. Now let me simplify everything. So negative 1 is greater than negative 4 plus 11. And we end up with negative 1 is greater than 7. Now, is negative 1 greater than 7? The answer is no, right? So this is not a solution. Not a solution. All right, let's try this one over here. Here we have a two variable inequality that this time it's not written in slope-intercept form, but it doesn't matter, okay? So I'm going to substitute a 3 in for the x value and a 2 in for the y value. So it's going to be 5 times 3 minus 3 times 2, and that's going to be less than or equal to 9. So let's see, 15 minus 6 is less than or equal to 9. And let's see, 15 take away 6 is 9. And 9 is greater than or equal to 9. So the question is this statement true? And the answer is yes. So because the statement is true, 0.32 is a solution to the two variable inequality. All right, how'd you do?